welcome everyone. Thanks so much for coming out. Today, we'll be talking about Coinbase's journey with Aeron over the years and our team's prequel to that journey. Before we get started, let's do a little bit of logistics. So, give me a show of hands. How many of you all are likely to be truthful if I poll you? How much poll fatigue do we have right now? Okay. Okay. Great. Just a bit of a temperature check. Anyways, let's talk about our team. So we're kind of responsible for the latency-sensitive exchanges here at Coinbase. We've been in the game for many years at this point across sort of lots of asset classes and multiple companies. But today, we'll be drawing most of our examples from a couple of our exchanges. One's the Coinbase Derivatives Exchange, and the other one is the Coinbase International Exchange. The bullet points serve to differentiate the two things, but as far as we're concerned, right, as an exchange engineer, I'm focused on the general problem for exchanges. Basically, exchanges, right, this is an order list of importance. Exchanges have to be correct and fair. If they're not correct and fair, there will be legal ramifications coming shortly. Next, exchanges have to be up, right? Like, you can think of an exchange as basically the bedrock for the markets on which they run, right? So, next step is a good bedrock is a nice and predictable and consistent bedrock, right? Like, this is a way we here at Coinbase can really differentiate our service compared to sort of other exchanges if our responsiveness and our performance and our behavior are highly consistent and predictable. That gives you all as exchange clients a nice little groove to do fun things, right? So we got to have all of these pillars or else catastrophe, right? The thing about an exchange is if we have a functional issue or if we have stability issues, it's not only us that holds the bag, but we could possibly seriously impact all of the customers and clients and partners that place their trust in us, right? So yeah, there's always a sword hanging over my head running an exchange. In fact, we care so much about consistency and availability that, okay, wait, show of hands, how many of you all are clients to an exchange? No? All right, yeah, okay. Okay, minus all the Coinbase people, my argument, my feeling is that there's an order of magnitude more clients of the exchange than people who work on exchanges. And here's my quip for you all. Basically, all of you exchange clients basically outsource your software reliability to us. Like if you're an HFT, submitting a bunch of orders 1,000 per second or whatnot, and your non-memory safe language seg faults, don't worry, we've got cancel and disconnect for you, right? Like you won't overfill, no worries. If you're some algo trader and you put extra zeros in your order, your quantity, or your price, again, no worries. We've got price banding, logic, all sorts of things to protect you all from yourselves, right? And I don't know, your machine breaks and your connection drops, you miss some messages, you send us resend requests from like last Tuesday, and we're not very happy about it, but we'll send you an absurd amount of data, right? So for us, right, we really care about correctness, transparency, ease of testing. All of our logic on the exchange is basically single-threaded, right? That makes things easy. One downside with being single-threaded is that if you want to scale, we're a business, right? Businesses have to scale. To scale, you got to be fast. So, right, enter Aeron, right? So in a previous life, we used to run an exchange called Curnex. It was an FX exchange, still is, still kicking butt, and it traded all sorts of different asset classes like treasuries, interest rate swaps, metals, you name it. Our journey with Aeron actually started with a YouTube video, not the of that talk that Martin gave at 𝗧𝗲𝗰𝗵𝗹. And better yet, Todd was also involved with Aeron, which made us really excited because we already were paying Todd's team, maybe not Todd at that point, but we were paying Todd's team for many years for a similar messaging product. So we started using Aeron, right, about 2015. Fast forward, we go and strike it out ourselves. We start an exchange from scratch, and now it's time to think about what are we going to use to have our services talk to each other, right? So classic question, do we build it ourselves? Do we buy something, or do we borrow something? No question. The reason why we chose Aeron, right, it was open source, and that DNA remains the most important thing for us and Aeron, right? Now, we were starting startups, so I understand you might think, okay, open source means free, but for us, what was great about open source is the source. As latency-sensitive engineers, we really cared about being able to see the underlying source code and collaborate directly with the maintainers to help shape the roadmap. And indeed, the team at Realogic and Adaptive have been just wonderful, right? And so we promptly started paying Martin and Todd again, right, as very happy customers of Adaptive now. So when we were going to start, we were going to build on top of Aeron Archive. We were going to do some sort of a primary, a hot primary, and a warm secondary matching engine, and use kind of like a sequencer-y approach. This architecture, fairly well known on the street, right? Like pretty popular for like about a decade or so. Also, some pretty common YouTube videos. But our kind of gripes with it was that primary, secondary, it's pretty hand-wavy, especially when it comes to like zero downtime upgrades, right? And we really wanted to crack the 24/7 nut, right? So, well, lo and behold, Aeron Cluster. Now, none of us had done our own exercises. None of us have like implemented multi-paxis from scratch or something. But like, Cluster is consensus with basically minimal messaging overhead. And the other thing we really liked about it, and this, I remember these conversations, where we loved the box it put us in. Running Cluster means you have an implicit requirement to make sure your state machine is deterministic. And the argument was like, all right, great. If you're deterministic, your testing is easy, right? You should be able to troubleshoot super easily. This is like the thought experiment that sold us. Let's say you're like running, your matching engine, something weird happens. Normally, you're kind of sad, right? You've got to go look at logs, you got to go read the code, what's going on. But like, let's say we're running in a distributed sequence log, or a deterministic state machine with a sequence log. When the behavior shows up, I can copy that log, I can copy the state, put it on my laptop. When I rerun it, same weird behavior shows up, and oops, I ran it all in a debugger. So if I can't figure out what's going on with like all the registers and everything, then I haven't seen that happen yet. But now we're okay. We still got to figure out how to mitigate, but at least we were able to figure out the root cause and all that. So yeah, we built this. We demoed to the CFTC and launched. And here's a bit of, I thought I should give you a legend for what you're seeing here. So we built a hot path inside a bare metal data center with co-location. And for history and long-term storage, we replicated out to AWS. So the three blue boxes are Aeron Cluster instances. We call that a monolith because we just put all of our logic in that monolith, right? And everything else is like, not really stateless-y, but like pretty stateless, trivial, right? Anyways, so we also have a replicator that runs Aeron Archive, runs replicate on the cluster log and the output. So specifically, right, if, Alice wants to buy like 2 Bitcoin contracts. It'll go to the leader, go to the follower, back to leader, and then we'll send the event that triggered out to everyone via multicast pretty quick. And then we'll also replicate those events out to the cloud. So that's all great. And we also like serialize it out to Postgres tuples or something like that. So blue arrows, just another term. Blue arrows are requests, right? So new order messages like new order single, and red is what you might think of as like an order submitted event, or like in Fix, it's like execution report or something, right? So one thing we noticed is that this is great, but what if Alice trades, right? One order will come in and you'll get a bunch of events that might happen based on the state of the system, at rest. Well, as a starving startup, right, the compute was pretty reasonably priced, or we had a good grip on that. But how they get you is those network egress and ingress outside, the VPC and data centers, right? So what would be really great is if instead of replicating, that mouthful, I just replicated the 5 pieces of data here. And what if I could just convert the requests to output events and send them over IPC? Well, luckily, Aeron can do all of such things, right? If we run our logic off of an archive of the sequence log, we can totally do this. So that really helped us out. We went from sending, these like big chunks of events. Notice how we kept the multicast, because that's really cheap, super fast, right? That's all fine. But when we're going across region, like, it'd be really nice to not, do that, like money on fire. So yeah, like, how does this actually work, right? Well, our logic, right, is deterministic. So what that means is we can replicate compute, right, sometimes instead of data in places, right? Because that's effectively what cluster is doing, right? You're replicating compute, right? So this was our first big post-production architecture change. We'd launched, and then we figured time to do the thing. So we did the thing, and that's kind of how we ended up sort of circa late 2021, I think. And like, if you don't have multicast, right, you can totally do the same thing in your primary data center, which is a bit of foreshadowing. Another nice thing that this lets us do, relying on archive, is we can do things like local queries. Your FSM effectively acts like a cache. It's like Redis, except has everything. It's much better, right? If I receive a request to query something, I can just send a request over IPC to my state machine, respond over IPC, and I don't have to query the leader of the matching engine. I don't have to query anything else. And I don't know, maybe if I don't want to run multiple copies of my FSM, I can just like run, one instance, right, in my VPC and just handle the network requests inside the VPC. So you get basically a spectrum of, you can either go all the way with replicating compute, you can go all the way with replicating data, but it gives you a bit of that slider thing. And that's been really nice for us. This also lets us separate read traffic from write traffic, right? Like, we have the single writer, which is the cluster, and the readers can just talk to their local, eventually consistent FSMs, which are pretty fast, right? Aeron's really fast, so this thing is lagging by like maybe a few microseconds, so it's like basically up to date. And so that's great. So forward, we get acquired by Coinbase. FairX becomes the Coinbase derivatives exchange. Yeah, that's great. Love Coinbase. Next year, we launch the Coinbase International Exchange. So this one, very much a not US-based exchange, lets participants come on, trade perpetual futures with margin and real-time settlement of trading proceeds. Difficult problem. The nice thing about what's relevant to Aeron is this is the first truly 24/7 exchange that we were building on this tech. the promise of the tech that we chose 5 years ago at the time finally paid off. Like, the international exchange is 24/7, has basically very limited downtime, so we upgrade our exchange like all time, every 2 weeks. And also, it's multi-cluster. We have multiple Aeron clusters talking to each other. Kind of tricky, but we do it, so a lot more complexity. What's next? Well, our topology basically changes with different combinatorics with various Aeron technologies and our data, right? So the more tools we get in our toolbox, the more we can kind of move those boxes you see around and do fun things with them. So yeah, like, I hope it's reasonably clear. Aeron's been a fundamental fabric for the success of our business and our tech stack. You know, basically, it's the communication fabric, right? It's our main persistence layer, and it's what protects us from machine durability issues and stability issues in both the cloud and the bare metal data center. And so we're really looking forward to more things that Adaptive can provide. But yeah, you know, thanks everyone. And if you got any questions, you can hit me up.